Okay, so from this diagram, we know that this is a complete revolution, and this is the center of the circle. Okay, and any line drawn from the center to any part of the circumference is radius. So we have indicated it with and here we have the angle theta sitting at the center of the angle, and opposite is y because this line corresponds to this section, which is the y-axis. Then we have this section to be x because it is on the line of the x. Okay. Now from this shape, you realize this shape has a right angle sitting here, making it a right angle triangle. Now from this right angle triangle, we know that sine theta equals the opposite of the angle, which is y, out of the hypotenuse. Then we have cos theta, which equals adjacent of the angle out of the hypotenuse, which is r. And tan theta, which equals opposite over adjacent. Okay. Now, from this triangle, we know of another theorem, which is the Pythagorean theorem. The Pythagorean theorem indicates that from the Pythagorean theorem, we know that hypotenuse square equals opposite square plus adjacent square. Okay? So, over here, from the shape that we have drawn from the circle, you realize that the hypotenuse over here is r, and that of the opposite is y, and that of the adjacent is x. So we can fix them inside. And this is going to give us r squared equals the opposite, which is y, so y squared plus adjacent, which is x, so x squared. From this equation, let's try and divide through by r squared. Okay, so we have by r squared. So we're going to have good. This is what we're going to have, and this is going to cancel this one off. Okay, and we are going to get 1 to be equals to, over here we have square here, we have square here, so we can put them together to have y on r all squared. You can do same to this section to have all squared. Now, from these ratios, the ratio that we have here, you can see that y out of r is representing something over there, and it's representing sine theta, okay? And x out of r is also representing cos theta, okay? So let's try and substitute each of them inside. So 1 equals to y out of r is representing sine theta, so we have sine all squared. Then x out of r is representing cos theta. So let's put, and here we have square sitting here, and this square in terms of trig, it is the sine or the ratio which takes what? The square. And this is going to give us sine squared theta. The same applies to this section. Good. And this becomes the first identity of trigonometry, which is sin squared theta plus cos squared theta equals 1. And I hope everything is clear.